Welcome to The Explainer. Today, we're going to unlock some of the mysteries of our most complex organ, the brain.
You know, our brain is basically the command center for everything we do, everything we think, everything we feel. So, what happens when it's under attack? That's what we're exploring today, from the slow, creeping erosion of chronic disease to, the sudden fury of an electrical storm inside our own heads.
All right, first up, we're going to dive into a condition that really hits home for a lot of people. It's something that affects our cognition by slowly, methodically stealing away what is arguably our most precious possession, our memories.
So, you've probably heard the words dementia and Alzheimer's used like they're the same thing, right? Well, it's a common mix-up. Think of dementia as the big umbrella term for memory loss. Alzheimer's is the most common type under that umbrella, but it's not the only one. And, telling them apart is actually super important for understanding what's really going on.
Now, here's where it gets really telling. One of the biggest ways to tell these apart is how they progress. With Alzheimer's, it's often this tragically slow and steady decline. But with vascular dementia, it's totally different. It tends to happen in these very clear, noticeable steps. A person might be stable, and then a sudden drop in function, often right after something like a small stroke.
Okay, so what is actually going on deep inside the brain? The best way to picture it is like a massive biological traffic jam. You've got these things called neurofibrillary tangles and neuritic plaques. Basically, they're like microscopic roadblocks that are physically clogging up all the highways our thoughts need to travel on. It's a total gridlock.
And all that damage on the inside, well, it leads to this really heartbreaking journey on the outside. It happens in 3 stages. It starts with that early confusion, mild memory loss. Then it moves into a stage of profound disorientation and needing more and more help. And finally, it reaches a point of complete reliance on others for literally everything.
The tough reality is, right now, there's no cure. And because of that, the whole focus of care has to shift. The goal isn't about reversing the disease anymore. It's about managing the symptoms, making sure the person is safe, protecting their dignity, and just preserving their quality of life for as long as humanly possible.
And that's why care for Alzheimer's is so much more than just pills. It's really about creating a safe, compassionate world for the person. Take something like validation therapy, for example, is a really powerful idea. Instead of arguing with them about what's real, the caregiver just acknowledges their feelings. It reduces so much stress and fear, honestly, for everyone involved.
Okay, so let's shift gears now. We're going to move on to a disease that poses a totally different kind of challenge. This one doesn't attack our memories. Instead, it goes after our very ability to control our own bodies.
So what is Parkinson's? At its core, it's a disease that attacks our ability to move. And it does that by draining the brain's supply of a really important chemical messenger called dopamine. Without enough dopamine, the brain just can't send out the clear signals it needs for smooth, controlled movement.
The disease really boils down to 4 main or cardinal symptoms. First, there's a tremor, but it's a specific kind that happens when the person is at rest. Second, you see rigid, stiff muscles. Third is something called bradykinesia, which is just a fancy word for a really profound slowness of movement. And finally, there's postural instability, which makes simple things like balancing and walking incredibly difficult.
Okay, so let's go back to that chemical imbalance. The best way to think about it is like a car's pedals. Dopamine is the brake. It provides that smooth, controlled stop. Acetylcholine, on the other hand, is the accelerator. It gets things going. In Parkinson's, the brake, it just stops working. So you've got this accelerator pedal that's basically floored with nothing to keep it in check.
So naturally, the whole goal of drug therapy is to try and get that chemical balance back. And the meds do this in a few clever ways. Some, like the famous one, levodopa, work by directly boosting the brain's supply of dopamine. Others basically act like dopamine imposters. They mimic its effects. And then you have another group of drugs that act like tiny bodyguards, protecting whatever dopamine is left from breaking down too quickly.
All right, let's switch gears again for a kind of rapid-fire look at a few other acute things that can really besiege the brain. We're talking powerful pain signals, sudden electrical storms, and even dangerous infections. First up, migraines. And I want to be super clear about this. A migraine is not just a bad headache, not even close. It is a complex neurological event. We're talking about debilitating, throbbing pain that, unlike other pain, serves absolutely zero protective purpose. It's just pain.
And because it's such a complex beast, the treatment is usually a 2-pronged attack. First, you've got what's called abortive therapy. These are the drugs you take the second you feel a migraine coming on to stop it right in its tracks.
Then, for people who get them a lot, there's preventive therapy. These are meds you take regularly to try and stop the migraines from ever even starting. Next up, epilepsy. Now, the key thing to understand here is the seizure itself. The best way to picture a seizure is as a sudden, totally uncontrolled electrical storm that just fires chaotically through all the brain's circuits. It completely disrupts everything.
So what do you do if you see someone having a major seizure? The number one priority is simple, but it is absolutely critical. Just keep them safe. That's it. Protect them from getting hurt, gently turn them onto their side to help keep their airway clear, and please never, ever try to force anything into their mouth. Your only job is to be a guardian until that electrical storm passes.
And finally, in our quick-fire round, let's talk about meningitis. Now, this one's different. This isn't a malfunction coming from inside the brain. This is an invasion from the outside. It's a nasty infection that directly attacks the delicate lining, called the meninges, that act as a shield for our entire central nervous system.
And this brings us to such a critical point. When it comes to the most dangerous forms of meningitis, and some of these can be fatal in less than 24 hours, prevention is everything. And our best form of prevention by far is vaccination. It's truly our best defense against this invader.
Okay, so we've covered a lot. We've talked about fading memories with Alzheimer's, losing control of movement with Parkinson's, debilitating pain, electrical storms in the brain, and even outside invaders. So what's the common thread here? What ties all of these incredibly complex and different conditions together?
Well, for many of them, it comes down to this. While scientists are, of course, relentlessly searching for cures, the day-to-day reality for patients and their families is something else. The focus has to be on compassionate care. It's about maximizing comfort, preserving dignity, and holding on to quality of life for as long as possible.
And that kind of care, it really rests on 4 essential pillars. Number 1, maximizing safety. Number 2, managing symptoms to make sure the person is comfortable. Number 3, maintaining their function and independence for as long as you possibly can. And number 4, and this one is so important, supporting the caregivers, the people on the front lines who are dealing with this every single day.
And that really leaves us with one last big question to think about. We're all living longer, and our understanding of the brain is getting deeper every year. So the question for all of us is, what are we going to do, both as individuals and as a society, to protect our most precious and complicated organ for the future?